So hello. I am Siddharth, and today I'm gonna code a model. This is a prediction model. This model predicts that is a person eligible for loan or not. So before starting this model, you should know three things. First thing is you should know pandas library from Python. The second thing that you should know is data transformation using Sklearn. And the third thing you should know algorithms. So I'm going to use three algorithms, which is k nearest neighbors classifier, standard vector classifier, and logistic regression. I am gonna choose the best output from them. So let's begin. So first let me import all the dependencies. I'm gonna import panda. So I'm gonna import, sorry for that, pandas as pd. And the next thing I'm going to import is from Sklearn dot model selection. We're going to import, this is the main thing, train template from Sklearn dot pipeline. We're going to import the make pipeline function from Sklearn dot linear model. We're going to import logistic regression from Sklearn dot neighbors. We are gonna import k neighbor classifier from sklearn dot pre-processing. We are gonna import standard scaler, and yes, we are gonna from sklearn import svm. I think this must be enough. We could add in further. Not, let me just check the data frame. Let us see what is data frame. So data frame is equals to pd dot read csv pd sorry my fault, pd dot, gonna call read csv function from here, and I've got a data set. Just copy its path and so df dot head. So first column we are able to see is loan id. This is the loan id. Then the second column we are able to see is gender. Then third column is married. Is the guy married or not? Then how many dependents are there on guy? Is it graduate or not? Is it self-employed? Applicant income, co-applicant income, loan amount. I could see some missing values over here. And I could see loan amount term, credit history, from where, what area does this guy belong, and is the loan status, means is that guy completed his loan or not, or is it pending or something, or is this guy eligible. So we're gonna come here, and first thing first I'm gonna check, as I could see some missing values over here in my data. So I'm gonna check df dot is null dot sum. I could see there are many missing values, so what I'm gonna do is I am call df dot drop any function. Now if I check that is df dot is null dot sum, you can see that there is no missing values, so we have just fixed the missing values. But we have also got a loss, as we have lost some rows, the data. So when I come further, sorry, we're gonna come further, and now we could see over here that all the missing values on the data is gone. So now we are gonna check what is the data types of all the columns. So I could see one thing, that only column number 7, 8, 9 and 10th column has float values, and column number 6 has an integer value. So I need to transform all these columns, and for that transformation we need to transform all these columns, so we could fix send data into algorithm numeric data. We cannot send this categorical data, so we need to transform data first. I got something for the transformation. Sorry, see, these are all the transformations that I applied on my data, and if I come, I do df dot head, you could see the data is transformed. But before we talk that what to transform, let me show you that all this is converted to either int or either float. See what I did. First things, I took the loan ID. So now what I could see inside the df of the loan ID is that df of loan ID has a lot of unique values. Like see, these are a lot and lot of unique values. Like see, but the one thing I could see is that the last 4 digits, if I could drop these digits LP00, I could work with these digits. So what I did, I just replaced LP00 with the empty string which removed LP00, and I converted into int as it was, as this was an previously it was an object. You will clearly see. Then I replaced a male with the value 1 and a female with the value 0, and I converted that to the integer data type. Then I replaced in the married column, I replaced yes with 1 and no with 0, and I also converted that to integer data type. Now for dependence, if I come, I actually noticed one thing over here that you should also check, that the df with dependence dot unique, you could see that there was previously a 3 plus over here, not a 3 value. So it was previously a 3 plus over here. So we could assume that it was more than 3 dependencies in the column. It was a 3 plus. So what we did, in that we remove the plus sign and convert that into integer. Now this is a loss, but instead of converting, uh, we don't know, so this is actually a loss of data. It might give us a loss in our prediction. Next is the graduate education of the employed. It has just two values, graduate and not graduate. I replaced graduate with 1 and not graduate value 0, and I converted that into int as it was an object. Then wait, I saw one error, and that is for self-employed. Wait, yes, yes, and yes. I saw an error in the self-employed. Self-employed, there are only two values, yes or no. Replace yes with 1, no with 0. Now in the properties area, there were three values: rural, urban, and semi-urban. I assigned urban 0, rural 1, and semi-urban 2. Converted that also to integer. Now the loan status is our target column. So this target column, that is a targeted column. We need to predict what is loan value. So now it is also an object, so I need to convert that first to an integer. So what I did, I assigned y1 yes 1 and n means no to 0 value, and convert that into integer. So now this is our target column. This is the, we run this str not with the string values. So we have got an error. What is that error? Let me see. You can use with the loan ID. It, you could fix this. Yes. Okay. is fixed. So now what I could do is that I need to target this from over here. So what I could do, I could do df. I need to keep all the values except the target column. So what I need to do is that instead of writing all the columns, I will do smart work and df dot drop. We are gonna columns. We always pass a list of columns that we need to drop into df. So what column we need to drop? We need to drop the target column, which is our target column is the loan status. So income here, we're gonna drop this. And in machine learning, you always keep the x capital and the y small. This is the like a pattern you do. So we're gonna keep the y, the target column in y. So now I'm gonna call train test split. I'm gonna call the class which is train test split and see. So let's yes. So what I've done, I have created four variables: x train, x test, y train, y test. I have called them train test split, passed xy, and keep test size 0. Means the keep the testing data 20% of the original data, and means the 80% is the training data. You okay? We are gonna run it. Children. Now before actually fitting this into the algorithm, what I need to do, I forgot to do one step. I need to transform this data. I need to transform this data into using a standard scaler. So what I could do, yes, what I could do that now I'm gonna call a pipeline. So what we are gonna do, we are first transform it and then fit into the algorithm. So we are gonna divide our work into two steps, step 1 and step 2. Our step 1 is going to call the standard scaler, and our step 2 is going to call an algorithm. So first I'm going to call logistic regression. So I'm going to call logistic regression. And now what I'm going to do, I'm going to create a pipeline. So my pipe is going to be equal to make pipeline function. I'm going to pass this both the step 1 and my step 2. What I'm going to do, I'm going to fit them into the pipe and x train comma y train. Okay, pipeline object is not sorry my fault. Pipe dot fit. I'm gonna call x train comma y train. See, this is my pipeline. So what the data will first pass to standard scale, and then logistic regression will be applied on the data. So y, the value of my y predict is equals to pipe dot predict, and I'm gonna pass the testing data, which is the x test data. So I'm gonna come up over here. I forgot to import one thing, which is from Sklearn dot matrices. I'm gonna import, as this is in classification algorithm, I'm gonna import accuracy score, and I'm gonna import mean square error. Yes, this is the best type of error I could find for these. Okay, so what I'm gonna do, I'm gonna first print the accuracy score, and I'm gonna apply that accuracy score on y test, and I'm gonna apply that on y predict, and I'm gonna do same with the mean square error. Apply y test comma y predict. So I could see that my accuracy score is 84%, so 0.84, so my model is 84% accurate. So what I'm gonna do, that I have applied first algorithm. Now I'm gonna again apply second algorithm. So now I'm gonna apply svc. So from svn dot svc, I'm gonna keep the kernel linear. to pipe dot fit, we're gonna fit, we're gonna fit exchange comma white. See, standard scalar SPC. Its kernel is linear, you see. Pipe dot predict, please predict on testing data, and we are gonna name it white predict 2. We have named it white predict 2. So now let's test the accuracy score. For this, I don't think so that it must be a lot of difference between SVM and logistic regression. And I was true, there's not, in fact, there's no difference between them. There's a very minor difference between them. Very minor difference. That is not affecting the model. So we could either choose the standard vector classifier or we could choose the logistic regression. Let us apply KNN because k nearest classifier. So we could apply the k nearest classifier. K nearest classifier. We are gonna do pipe dot. First we're gonna fit it into the pipe. And what we're gonna fit? We're gonna fit X train, Y train. We're gonna do pipe dot predict. What we're gonna do? What we're gonna predict? We're gonna predict X test, and we're gonna name it as Y predict 3. We are gonna again import. Well, sorry, not import. We're gonna check the accuracy score. So it is 83% and mean square error is 16%. Not much difference in any of these algorithms. So now let us see. So we are gonna do df. Let us see that is our algorithm working perfectly or not. We're gonna print for, let's check it. First thing is for logistic regression. In a second, it's saying first means the person should be eligible for a loan, and we could clearly see that the second says the person is eligible for the loan. Now we will come over here and again copy this, paste this, y predict 2, y predict 3. It's saying yes, the model is working perfectly. So now what I could do further is that I could actually add front end using Flask and add more parameters, make it more accurate using uh, algorithms, more complex algorithms like uh, random forest or something. So you could add many more to the project. I will add the GitHub file and the dataset below. Thank you for watching.